Alrighty, welcome to Arithmetic Series Part 3. And what I'm going to do is a couple of loose ends here. We're going to try to work through just a couple of different examples. Like the first one that I wrote here, it says we're going to write this series 8 plus 11 plus 14 plus ... plus 107. We're going to try and rewrite this using sigma notation. So, how are we going to do that? Well, first thing we got to do is figure out just how many terms we have, because when we think of sigma notation, it's using the sigma letter, or the Greek letter sigma. Then we're going to put in a counter, and we usually start at 1, but how far do we take this? When does it end? So that's kind of like step 1. We want to figure out how many terms there are. And when we look at the terms of the series, we can see its arithmetic growth. One thing we can spot is the first term is 8. The common difference is 3. We seem to be adding 3 each time. And that's as much as we know. We don't know how many terms. So what I'm going to do is go to this formula here. T sub n equals the first term a plus n minus 1 times the common difference. And we're going to say we know the value of that term. It's 107. And we know that a is 8. What we don't know is what n is. So we're just going to keep plugging in what we do know. We know d. And now I'm going to go ahead and solve this for n. So take 8 away from both sides. So we're down to 99. Then I have n minus 1 times 3, and then divide the 3 over, so that's 33 equals n minus 1. Well, guess what? If I add 1 over, I now know that there are 34 terms. So what I think I'm going to do over here is if I put a 34 up here, is that going to be the correct number of terms? Well, I'm going to check it. I'm going to take the top number, 34, and I'm going to minus the bottom number away from it, and then I'm going to add 1. And you might remember that that's how you can check how many terms you'll have. And of course this ends up being 34, and that's how many terms we want there to be. We want the last guy here, the 107, to be term number 34. So we've got part of the sigma stuff figured out. What we now need is in here the rule as to how do we get the terms to be produced. So what I'm going to do is I'm going to go back to this formula here, and I'm going to say I'm going to put in what I know of that formula. So I'm just going to clear away this stuff here, so I don't need that anymore. Okay, so we're going to get rid of that. And here's what I do know about each term. So whatever the term is, I think a is always going to be 8 for this particular series. Okay, now n of course changes, but the common difference is always going to be 3. So I think this is how we figure out any given term for this particular series. Now I'm going to just expand out the brackets, and by doing that I'm able to simplify it down a little bit further. I can go 8 minus 3, so that's 5 plus 3n. So that's how you get any particular term. You just go 5 plus 3 times n. Now, when I put that into here, into my sigma statement, we're not using n, we're using k. So we just want to put that in with the correct variable. So 5 plus 3 times k. So I think this is our answer. Might be a good idea to check our work just to make sure everything's working out okay. So what I'm going to do is just try running through a couple of terms here. So suppose we started off, we put in 1. We would get for our first term 5 plus 3 times 1. So that would be our very first term, and of course, what's 5 plus 3? It's 8, and that's what we want our first term to be. So that one checks off. And we go plus, and then k gets bumped up to a 2. So our second term looks like this. 5 plus 3 times 2, and that's 5 plus 6, so that's just 11. So I go, hey, 11, that's perfect. So I'm just going to assume the rest of it is working okay. We checked a couple of terms, and it looks good. So that's my first example. And that's just taking any series that's arithmetic, and how do we work that and rewrite it using sigma notation. Okay, the last thing I'm going to look at here is finding something we call the arithmetic mean. So arithmetic mean. And now mean is a fancy word for the average. So what that is really referring to is if you had a couple of terms, let's say you had a 2, and then you had, let's say, a 5, and then you had 8, we would say, aha, 5 is the arithmetic mean between 2 and 8. Or sometimes you can put in a couple of arithmetic means. Suppose we had 2, and let's say we had blank, blank, and then we had 11. I could look at this and say, well, I think the 2 arithmetic means between 2 and 11 are 5 and 8. And of course, I'm using a very simple one here that we can see just what an arithmetic mean or a couple of arithmetic means actually is. So that's what an arithmetic mean is. Now, what if we have an example where it's not quite so obvious? Let's say we want to go 5 and we want to put a mean between 5 and 20. So we go, got to figure out the arithmetic mean that goes between these two numbers. Well, here's how we do it. We know that we're going to add a common difference. So we know that this mean is going to be 5 plus d. And if we add another common difference, we should get 20. So 5 plus d plus another d, or 5 plus 2 d's, would equal 20. Well, this gives me an equation. I can go 5 plus 2d has to end up equaling 20. And so I can solve this equation, take 5 away from both sides, and then we'll divide by 2. Whoops, didn't really take 5 away there, so just a moment. 15, yes. And then we'll divide by 2, so we would get 7.5 as the common difference. So what does that make the mean? Make sure you answer the question. If you're looking for the arithmetic mean, that's the number that goes in between the 5 and the 20. So that's going to be 5 plus 7.5. And so our answer is 12.5. So that would be our arithmetic mean that between 5 and 20. And that's pretty much all I'm going to say about series, arithmetic series, at this moment in time. So I'm going to stop right there.